Hey guys, welcome back to 100 Days of Code. Today we're going to look at debugging, the process of removing bugs from your code. If you managed to get to this point, you've probably written quite a bit of code already. And I will bet that you've probably made some mistakes, some typos, some errors, and some bugs. So in this lesson, I want to talk about some techniques and tips for how to find bugs and how to get rid of them from your code. Now, the first documented bug was actually found by this lady, Grace Hopper. She was probably one of the first programmers and one of the pioneers of the job that we're undertaking right now. Now, in her notes, you'll find a moth that's been taped to the notebook. And this was found in a relay that was preventing her code from running properly. And this was pretty much the first actual case of a bug that's been found in a computer. Even though we're not dealing with moths these days anymore, we're still going to end up finding bits of things in our code that prevent the code from doing the things that we want it to. The important thing to remember is don't feel down when you've created a bug, because everyone gets bugs. And when I say gets bugs, I mean we create them, right? So once you've gotten over this, next I want to talk about some of the tips and techniques that you should follow on how to quickly be able to identify and remove these bugs. So the first step is to describe the problem. If the problem is messy and it's not well understood in your head, then it's almost impossible to debug it. So untangle the problem and try to make sense of what's going on. To begin, go ahead and fork the starting REPL for today's code. Now, the first thing to notice here is that I've written a bunch of code in the starting REPL, and we're going to be uncommenting these blocks one by one and eventually solving all of the debugging problems. So the first thing you're going to do is to uncomment the first block of code. Now, in this block of code, we're going to practice describing the problem to help us solve this debugging problem. Now, if you take a look at this function, you can see that at some point in the function, we're supposed to print this line out into the console. But if we go ahead and hit run, you can see that nothing gets printed. So what's going on here? I want you to take a look at this function and describe the actual problem. What is the for loop doing? When is the function meant to print "you got it"? What assumptions are you making about the value of I? So pause the video, read the function, and have a go at describing the problem. All right, so what we've got here is we've got a function that loops through all the numbers between 1 and 20, and then once that number reaches 20, it's supposed to print "you got it." But the problem is that when I reaches 20, it doesn't print this line into the console. So now that we've described the problem and we understand what's going on, let's see if we can solve it. If we think about this problem, when I reaches 20, it doesn't print out this line. There's an assumption in there, right? The assumption is that I will definitely reach 20. But if you think back to how the range function works, the stop or the upper bound is actually omitted. So when you write range 4, it actually produces a number from 0 up to 3. And in our case, when we write 120, it actually goes from 1 all the way up to 19, but not including 20. The problem here is that I actually never reaches 20. So this assumption is completely false. Pause the video and see if you can fix the code so that this line actually gets printed. All right, so all we need to do is change this to 21 instead of 20. And now when we hit run, you can see it actually works and we managed to debug this problem. Always, when you come across a problem in your code, try to describe it so that you really understand what the issue is, and then test your assumptions and see which of those assumptions is actually false. Now, the next step is to think about reproducing the bug that you've encountered. Because when you encounter it once, but you don't encounter it the next time, that becomes a really difficult bug to fix. Go ahead and uncomment the next block of code. And we're going to comment out the previous section because we're done with it now. So this is the only part that should be active in your main.py. In this section, we're going to try and reproduce the bug. So when we run the code, sometimes it will work and it will print out one of the dice images from this list, but occasionally you will get an error. These types of bugs are really difficult because you might test your code only once or twice and it looks all fine, it works, but then occasionally you get an error. And the important thing is to reproduce that error. When does that error actually happen? And based on that knowledge, we can fix our code. Try to reproduce the bug yourself and try to notice when it happens and see if you can change the code so that it always produces this error. We've got a list of dice images, which are just emojis, and we've also got this random number, dice number, between 1 and 6. Now, when we try to pick out of our list, occasionally we get an error. Now, we have to notice when the error occurs, and to reproduce the bug, we have to figure out which of these numbers is actually causing the problem. So we know that this is a random number between 1 and 6, and if we check the documentation, it tells us that randint works a little bit differently from range. It will return a random integer in the range of A and B, including both endpoints. So in our case, both 1 and 6 could be generated, and it could be any number. So if that was equal to 1, well, does it generate an error? No, it just picks out this particular item. But what if it was 2 or 3 or 4? Or what if we tested 6? Well, now every time we hit run, you can see we get an error. And now that we've got our error to show up consistently, it's a lot easier to debug because we know that the index error, list index out of range, happens when this dice number is 6. So when we go back to our previous code, well, we can't use 6 in this list because lists start counting from 0. So to get this dice 1, we need dice num to be 0. And then this is 1, 2, 3, 4, 5. And 6 is somewhere out here and it doesn't exist. Now go ahead and fix this code so that all the dice images are represented and we never see this error again. All right, so that is as simple as shifting down these numbers. So instead of making a random number between 1 and 6, we actually want a random number between 0 and 5. And now, no matter how many times we run our code, we're never going to get that error show up again. Very often, I've asked you in the quizzes especially to play computer. And the reason is because this skill of pretending to be a computer, reading through your code and imagining what you're going to do each time is really, really useful, especially when you're debugging. So let's comment out the previous block and try the next block. Take a look at this code. It takes an input in the form of an integer and it asks the user for their year of birth. And then it uses an if statement to check if they were born between 1980 and 1994, in which case they're classified as a millennial. But if they were born later than 1994, then they're classified as a Gen Z. So depending on which country you're from, there's different classifications for your particular generation. This is just the typical words that you hear on the internet. You're a millennial, you're a Gen Z, you're a baby boomer, and this comes from a lot of the history of the US. But nonetheless, I want you to run the code and I want you to see what happens when I put in 1994. Absolutely nothing. So we have our bug right there. Run through the code line by line and evaluate each statement. For example, if year is equal to 1990, will line 77 evaluate to true or to false? What if year is equal to 1994? Look at each line of code and follow the logic and check what it will evaluate to. So I want you to play computer and figure out what is the problem and then go ahead and fix the bug. Pause the video now. All right, so let's pretend that we got 1994 as the input. So now I'm the computer and I know that this year is equal to 1994. Now, with this year being equal to 1994, I go into this if statement. So is 1994 greater than 1980? Yes, it is. So this actually becomes true. Now I have to check the second condition, and it also has to be true for this if block to be triggered. So is 1994 less than 1994? No, it's not. It's actually less than equal to 1994, or it's equal to 1994. So in this case, this condition becomes false. And we know that if we try to combine a true and a false, then it actually just becomes a false. So this gets skipped. Now next, we look at the next statement, right? If 1994 is greater than 1994, well, that's also not true. It could be greater or equal to, or it could just be equal to. So this condition is also false. So that means it's also going to skip this next line, and there's no more lines of code left, which is why the computer doesn't print anything. So let's restore our code to before we started playing computer, and we can identify that this problem occurs because there is no bucket that actually catches the 1994. We could simply fix this code by changing one of these conditions to be greater than or equal to either here or here. And that means that the year 1994 is not skipped over in our conditions. And when we hit run, it'll actually tell us that we are in fact a Gen Z. Now, the next step and the next tip is pretty obvious. When the editor is giving you an error or when the console is giving you an error, fix the errors before you continue. Now, this is a little bit easier when you're dealing with errors in the editor because it'll actually highlight to you the line that's broken. So here we've got a print statement, and when we hover over it, it tells us that it expected an indented block. So that should be a good enough clue to tell us what's actually wrong. So if we go ahead and indent this block, then that error goes away. But that's not the only error. No, when you run this code, you still get another error. So let's say that I am a 12-year-old girl. We get another error. And this error does not show up when we write the code, but it only shows up depending on what input we gave to this age variable. So now we have a different type of error. We have an error that's in the console. How do we solve this error? Well, the easiest way is just to select the parts of the error that's not specific to your code, like this age greater than 18 or line 84, but the part that is pretty much common to whenever anybody gets this error. And now if we copy it and we paste it into Google, then you can see there's a lot of other people who've had this issue. And if we read what the problem is, it tells us that you're getting the input from the console as a string, and you must cast that input as an int before you try to do these numerical operations like comparisons. Back over here, that's exactly what we're trying to do on line 84, right here. This age comes out of this input function and it returns a string. And so in order to turn this into a number, we of course have to cast it or type convert it into an integer. And now when we run our code and we give it our age, it no longer errors out. And if I tell it that I am in fact 21, which is still not my real age, then we actually get the print statement working. But remember that the errors don't always solve all of your bugs, like this. In this case, there are no errors with my code whatsoever. It's just not doing what I want it to do. And these are the most frustrating bugs to debug because nobody is helping you here. There's no errors that you can Google. There's no underlines that you can check. You actually have to rely on your skills as a programmer to fix this. Now, we, of course, know that this needs to be an F string in order to insert that variable into this position in the curly braces. But if you didn't, then this would be a lot harder to debug. Experience comes in really handy with debugging, and the more bugs that you solve, the better you get at it. So go onto the internet, try to help people on Stack Overflow, go on to the Discord channel for the course, try to solve other people's bugs, and you will find yourself getting stronger and better day by day. Now, the next tip has been the thing that you've probably been screaming out for. Why don't we use print? And indeed, you are correct. Print is basically your best friend. Now, as developers, I know we don't have a lot of friends, but at least we can rely on print to be our trusty friend. Do you have heartbreak? Use print. Now, print probably can't help you with your relationship issues or family issues, but it can help you debug your code, which is a pretty decent thing for it to do. So let's go ahead and comment out the previous block and let's uncomment this one. And now I'm sure you're pretty much dying to use print to solve these debugging issues. Why, Angela? Why haven't you been using it before? Well, I've been saving it for this perfect moment. Take a look at the code and see if you can use print as your friend to help you solve the issue. Pause the video now and give that a go. So here we've got a very simple program that figures out the number of words in a book. Pages starts out 0, words starts out at 0, and we have to input the number of pages in our book and the number of words in our book. And then we multiply the pages by the words to calculate the total number of words in the book, and then we print it out. But if we have a go, you can see that, let's say we have 45 pages making a booklet, and we have 250 words per page, and we get 0. So the output that's supposed to tell us the total number of words in the book ends up being 0. So what's going on here? How can we debug this? Let's go ahead and use print. What are our assumptions? Well, we're actually getting the number of pages and the number of words correct so that we can calculate this. Why don't we add some print statements before the final one? Let's print what's the actual value of some of our variables that we're getting from the user. For example, I could say the pages equals, and then insert the pages variable in here in an F string. And I can also print my other variable in an F string, which is the word per page variable. And this is equal to, let's insert that variable as well. And now when I run my code, I've got my print statements going and I can test it out. So we've still got 45 pages and then 250 words per page. And now you can see that my variables are logged. So this one, this pages variable, does equal 45, so it captured my data correctly. But the word per page equals 0, which is not what I entered at all. I entered 250, so I was expecting this to be 250. So now, using print, my best friend, I've managed to narrow down the problem. It's something to do with this variable. So let's take a look at what's going on here. Well, I've spotted the problem. Have you? Pause the video and see if you can fix this code so the final total number of words actually gets printed when you run the code. Pause the video now. All right, we've narrowed down to this one line of code that's probably broken. And if you look closely, you'll see that instead of a single equal sign, which means assignment, this variable should be equal to this value. We had 2 equal signs. This means, does this variable equal this value. And this actually gets evaluated and becomes either true or false. Now, in this case, it's actually false. Words per page starts out being equal to 0, and then it becomes equal to 250. So if this line of code is false, then that's just left as it is. It doesn't actually affect anything. And this total words is still using 0, which is why it's printing out 0. So now that we've identified the issue, all we have to do to fix it is that. And if we run our code again, you can see it works exactly as it should do. Now, before you start getting really committed to print and start making friendship bracelets for this print statement, there's another tool that I really want to talk about. And it's a tool that's bigger, it's fancier, it's more complex. So what is it? It's a debugger. And we've already seen debuggers a little bit. So I've already shown you pythontutor.com, and you've also seen us use the debugger in the Thonny editor right here. Now, in this example, I'm going to stick with the web version of Python Tutor just so that you don't have to install anything extra. But if we go ahead and comment out the previous block and uncomment the last one, you can see that we have yet another problem to solve and yet another piece of code that's not doing what it's supposed to do. So in this case, we've got a function that's supposed to mutate a list so that it takes a list as an input, and then it's supposed to multiply each of the items in the list. So the final output should be something like 2, 4, 6, 10, and so on and so forth. Basically taking each of these numbers and multiplying them by 2, which happens on this line of code. But unfortunately, when we run it, we just get a list with a single value, 26. So what's going on? Let's try and debug it. So I want you to copy these lines of code and then paste it into Python Tutor, and then go ahead and click Visualize Execution. Now that it's inside the debugger, we can do a lot of things with it. We can step through the code to see it line by line. So for example, the first thing that happens is we create a function called mutate, and this mutate gets passed a input called a list. So now inside this function mutate, we've got a variable called a list, and it's this list with these values. Now, as we keep going, we can see we create a B list, which is an empty list, and then we use the for loop to loop through each of the items in the list. So the first time this item is equal to the first item in the list, which is 1, and then we multiply it by 2 to create this new item variable, which is now equal to 2. And now the loop goes back to the beginning, and we keep doing this with each of the numbers in the list. We multiply 2 to each of the numbers. Now, once we're done with that loop, the next line that happens is this one. This B list gets appended with the new item, and finally, we print out the B list. Now, this is where the problem occurs. Notice how B list is just a list with one value, and that is in fact what gets printed. So with this debugger, we've managed to see line by line what the computer is doing, which is really helpful in itself. But we can actually make this process even simpler. Inside most debuggers, you can put a breakpoint, which tells the computer to stop what you're doing at this particular line. And then at that moment in time, I want to examine what all the variables and all the functions are doing. So in our line, the key problem happens right here. So if I click on this line, you can see it becomes red, and this is where it happens. This is the breakpoint, basically. So now I can scroll over to that point in time, and I can examine the values of all of my variables. A list is still what I expect it to be, but B list is completely empty. And this item happens to be on the last item, number 13, and the new item is doing what it needs to do, multiplying it by 2, but none of them are being added to my list. Because if I click next, you can see this B list is equal to just one value, and it happens to be the last value that new item was equal to. So by using this debugger, you should now have a good idea of what the problem is. Pause the video and try to fix this code so that the mutated list with all of its 6 values gets printed. Pause the video now. Alright, so the simple problem is that when we're adding the new item to this B list, we're doing it outside the loop. It's when this loop has completed and at the very end do we actually call this line. So what we needed to do to fix this code is just to indent that line over. And now when we run the code, you can see that the proper output gets printed. And if we change this code inside the debugger, if we edited it right here, then when we visualize it, you can see if I put a breakpoint here, that line of code gets executed 6 times. And if we go to that line of code and we hit next, you can see that the B list is now getting new values added each time, as we would expect it to. And when we examine all of our variables, especially this B list variable, it's exactly what we expect it to equal each step of the code. So a debugger can be really useful. It's almost like you've put a print statement on all the variables in your code, and you can isolate a particular time point to see what each of the values are. And as we become even more experienced, we're going to be using the debugger more and more.